Hi guys, I'm Professor Adrijana Savic and I work at Kennesaw State University. Today I will try to explain strain. So what is strain? Strain is the deformation or displacement per unit length of material. We have some sample which is subjected to pulling force. For instance, if we have pulling force at the end of the sample, which is shown in figure 1, then we'll have extension in the length. So that difference between original length and extended length over the original length will be our strain. Or if we have a pushing force at the both ends on the sample, then this sample will be shrinked, and again we will have some changes in the length, original length and the new length, and that difference between the original and the new length over original length again will be strain. This is normal strain. Again, we will have the other type of strain, which is, for instance, shear strain, that is due to tangential force, where we will measure angle change, and of course we will have some strain due to temperature change. Imagine that we have some steel which is subjected to high temperature. Then we will have a strain which will be given using the formula alpha t times delta t times L. Delta t will be the difference in the temperature. Alpha t is thermal coefficient, which is given to you regarding to the type of materials, and L will be the length of the sample or the material, etc. So we have different types of strain: normal, shear, and strain due to temperature. And normal strain occurs when a material is stretched or compressed. The strain doesn't have any units, and it can be positive if we have elongation and negative if we have contraction. And shear strain is caused by forces parallel to the surface. So formula will be gamma is equal tangent of the angle, for instance theta or alpha, like it is given here in this figure. So you have, for instance, on T profile we have two flanges, one web, and on flanges we have one force. So this will give us the change in the angle if we are considering the web. So we will have a difference between the original position and the new position. So that is our alpha or theta. So shear strain is a measurement of the amount of distortion associated with the sliding of plane layers in a distorted shape compared to its original form. And again, I mentioned that we have a strain due to temperature change. Again, we are using the formula alpha t times delta t times L. So delta t is the change in temperature, alpha t is thermal coefficient, and we have L as a length of the material. So for engineering strain, we have epsilon, that is equal delta L over L naught. So that is when we are using some assumptions or idealization of the conditions, but true strain will be ln L over L naught, and this is important for large deformations. Stress-strain relationship is given by Hooke's law, where we have that stress is equal modulus of elasticity times strain, and this is only applicable in elastic range of sigma epsilon diagram. So that is something which we will cover in some future videos, where I will explain ductile sigma epsilon diagram and brittle sigma epsilon diagram. So sigma is stress, E is modulus, Young's modulus of elasticity, and epsilon is strain. So there are different ways how to measure strains. The one is strain gauges, then we have digital image correlation, extensometers, etc. Strain gauges, they can't measure directly the strains. We are using indirect method, and again I will explain that in some future videos. So we have strain in real world application. Usually we are using strain gauges on bridges and buildings, aircraft and automotive, biomechanics, etc. And as a summary, we have strain, which measure deformation, two main type, normal and shear, and again strain due to temperature. It is crucial for safe structural design, and it can be measured using various technologies. So this is for now. Thank you for your attention.